Hello everyone and welcome back to the channel. In today's video, we're going to take a deep dive into implementing a stack structure using linked list in Java. Stacks are fundamental in base IT, and understanding how to implement them is crucial for any aspiring programmer. So grab your copy and let's get started. So in this tutorial, we'll cover everything from the basic definition of stack to the nitty-gritty details of the Java code. We'll also walk through a practical examples to see our stack in action. So, first, let's clarify what a stack is. A stack is a linear data structure, which means elements are arranged in a sequential manner. Think of it as a collection of items where you can only access the most recently added item. This defining characteristic of a stack is that it operates on the LIFO principle, last in, first out. This means that the last element we insert in the stack is the first one we remove. It's like a stack of books. You always take the book from the top, right? The last book you place on the stack is the first one you will pick up. So a great example is the undo redo functionality. In many applications, the most recent actions you took is the first one to be undone. That's the stack principle at work. So stack are extensively in compilers, operating systems, and algorithms. They are essential for managing function codes, evaluating expression, and many other tasks. So common operations. So now let's discuss the common operation we can perform on stack. This operation define how we interact with stack. So first is the push. This operation inserts an element on the top of the stack. It's like adding a new plate to the top of the stack. So next is pop. This removes the stack. This removes the element from the top of stack. It's like taking the top plate of the stack. So next is pick. Allow us to view the top element without actually removing it. Imagine looking the top plate to see what's there without taking it off the stack. So next is SMT. This check if the stack is empty. It helps us avoid errors when we try to pop or pick from an empty stack. So each of these operations is crucial for managing the stack correctly. Push adds new data, pop removes data, pick allow us to inspect the stack, and SMT helps us to maintain the integrity of our data structure. Now, let's break down the Java code for implementing a stack using a linked list. Line by line, I'll focus on the important parts. We need a stack as linked list class and its inner stack node class. So in our code, so we have a stack as linked list. This line declares a public class name. Stack as linked list. This class will contain the implementation of our stack using a linked list. Might just be a slide numbering or annotation. So next is stack node root. This line declares a variable name root of type stack node. The root node will represent the top of our stack. It's the enter point to the linked list. If root is null, it means the stack is empty. So third is static class stack node. This line declares a static inner class name stack node. This class represents a single node in the linked list. Making it static means it associated with the stack as linked list class itself, not with any specific instance of class. So int data, this declares an integer variable named data inside the stack node class. This variable will store the actual value that the node holds. You can change int to any other data type, like string or double, if you want to store different type of data in your stack. So stack node next. This line declares a variable name next of type stack node inside the stack node class. The variable is a pointer to the next node in the linked list. It's what links the nodes together to form the chain. So stack node int data. So inside of it is this.data equals data. These lines define the constructor for the stack node class. It takes the integer data as input, initialize the data field of the new node in this value. This data equals data part is important because distinguishes between the data field of the class and the data parameter. So pass to the constructor. So public boolean is empty. So this line defines a public method name is empty that returns a boolean value. This method is used to check if the stack is empty. So if root equals to null, this line checks if the root node is null. If not is null, it means the stack is empty because there are no nodes in the linked list. So next is return true. If the condition in the if statement is true, this line returns true, indicating that the stack is empty. So else, if the condition in the if statement is false, the code inside the else block will be executed. So return false, this line returns false, indicating the stack is not empty. Public void push. This line defines a public method named push that takes an integer data as inputs and add a new node with data to top of stack. The void keyword indicates that this method does not return any value. So next is stack new node equals to new stack node data. This line creates a new stack node object name new node using the new keyword. The constructor of the stack node class is called when the input data to initialize the data field of the new node. If root equals to null, this line checks if the root node is null. If root is null, it means the stack is empty, and the new node will become the top of stack. So root equals to new node. If the condition in the if statement is true, root is null, this line sets the root node to new node. This means the new node is now the top of stack. Else, if the condition in the if statement is false, the code inside the else block will be executed. This means the stack is not empty, and the new node needs to be added to the top of the stack while preserving an existing node. Stack node temp equals to root. This line creates a temporary variable named temp of types stack node and assigns it the value of root. This is done to store the current top of stack before it replaced with a new node. Root equals new node. This line sets the root node to the new node. This means the new node is now the top of the stack. New node that next equals temp. This lines the next pointer to the new node to the temp node. So system that out the print line data push to stack. This line print a message to the console indicating that the new code has been successfully pushed on the stack. It displays the data value on the new node along with the message push to the stack. So next is this slide shows the pop and pick method along with the driver code in main and the corresponding output. So in the pop method, if the stack is empty, root equals to null, it prints stack is empty. Otherwise, it stores the data of root node into a pop variable. It moves the root to the next node. Root equals to root.next, effectively removing the top element. It returns the pop value pick method. So we are now in pick method. Stack is empty. Now root equals to null, it prints stack is empty and returns integer, which is mean value. Otherwise, it returns data of the root node, the top element. Driver code, which is a main method, creates an instance of stack as linked list, pushes the value 10, 20, and 30 into the stack, pops an element and prints the pop value. Pick at the top element and prints it. So the output shows the order in which elements are pushed on the stack, which is 10, then 20, then 30. Shows that 30 is pop, which is the LIFO. Shows that the top element of the pop is 20. Show the remaining elements on the stack are 20 and 10. That's it for today's tutorial on implementing a stack using a linked list in Java. I hope you found this helpful. If you have any questions, feel free to leave them in the comments below. Thanks for watching.